in lesson 55, we're looking at advanced abstract equations and word problems and quadratic equations. In example 1, this is an advanced abstract equation, and we're going to solve for m. So what I'm going to do is just multiply everything by my common denominator of xm. So on the first equation, since it already had an x on the bottom, the x's would cancel, and I just need to multiply across by an m. So I'd have ma plus mb. And then on the second fraction here, the m's would cancel, and I would have an x to multiply with my y. So I'd say plus xy, and equals k xm. Because the k only had a 1 on bottom, so nothing would cancel. Alright, now I don't have anything in my denominators besides a 1, and since I'm solving for m, I want to get all my m terms on the same side. So I'll need to move this to that side, and then I can move this over here. So I'm going to have ma plus mb minus, because you change sides, change signs, kxm equals a negative xy. Alright, now I'm going to factor my m out. So I'll have m times a plus b minus kx equals a negative xy. And then I just need to divide by that a plus b minus kx. So a plus b minus kx. And here it cancels, so the m equals the negative xy over a plus b minus kx. And that's our answer. In the next one, I'm going to again multiply across by the common denominator. This time it's a cx. So on the first one, the c's would cancel, and I just need to multiply by an x. So I'd have x np. And on the next one, the x's would cancel, so I'd need to multiply across by a c. So plus cd plus ce. And on the last one, nothing cancels, so it's cxd or cdx. Alright, now since we're solving for x, I need to get all the x terms together. So I'm going to just move this one by subtracting it on the other side. So I'll have a cd plus ce equals cdx minus xnp. Now I'll factor the x out, so x times cd minus mp will equal the cd plus ce, and I'll divide by the cd minus mp. And those will cancel. So x equals cd plus ce over the cd minus mp, and that'll be our answer. Alright, and the next one's similar, except this time on the bottom I have an a plus b. So my common denominator will be y times a plus b. So on the first one, the y's would cancel, so I need to multiply the mx by the a plus b. And the d will be multiplied by the y because the a plus b would cancel. And the p will be multiplied by the y and the a plus b. Okay, so I'll need to use the distributive property here. So I'll have ma plus mb plus by equals, and then I'll distribute that py across, apy plus bpy. Okay, now I'm solving for a, so I'm going to get my a terms on the same side. So I'll move this ma over here by subtracting it, And then I'll take this bpy and subtract it to the other side, so I'll have my a terms by themselves on the right side. So I'll have na, well, let me just write this. NB plus by minus that bpy, and again I'm moving this to the other side, so it'll be equals apy minus na. Okay, so I'll factor the common factor out, so I'll have an a times py minus m, and that's what I need to divide by, is that py minus m. And then that is what my a equals. Since I'm running out of room, I won't rewrite that again. Alright, and then our last example, we have one of those consecutive integer problems. It says to find 3 consecutive integers such that the product of the first and third is 4 greater than 4 times the second. Okay, so we're just having consecutive integers. So it'd be n plus 1, and n plus 2. And it says the product of the first and third, so that's my first and that's the third, so n times n plus 2 is, so that's equals 4 greater, so 4 plus, then 4 times the second. So 4 times, this one's the second, so it'll be n plus 1, right? So I'll distribute my n across, so I'll have n squared plus 2n equals 4 plus 4n plus 4. So I'll go ahead and get my like terms together on this side. So I'll have n squared plus 2n equals 4n plus 8. So I'll subtract my 4n from the 2n, so I'll have n squared minus 2n. I'm going to subtract my 8 to move it on the other side, so it'll be equal to 0. And now we need to solve this by factoring. So I'll have an n and an n to get n squared, and then factors of 8 that have a difference of 2, so that'd be 4 and 2, and since this middle is negative, my bigger number needs to be negative. And then I'll set each of them equal to 0 and solve. So n minus 4 equals 0, so n equals a positive 4. And then n plus 2 equals 0, so n equals a negative 2. So I'll have 2 possibilities. So it can either be a 4, 5, 6, or we could have negative 2, negative 1, and 0. Now, for your answer, you need to include both of these, because they're both possibilities that you could fill in the numbers, and this situation or equation would work for both of those.